All right, so in this problem, we're trying to find the one-sided limit. So we're trying to find the limit as x approaches 6 from the negative side or from the left-hand side. So the first thing you always want to do is check to see if you can just plug the number in. If you can plug the number in, then you just evaluate, and then whatever you get is your answer. Now, in this case, if you plugged in 6, you would get 0 over 0. You would get 36 minus 36 in the bottom, in the denominator. And then so that wouldn't be okay. So you got to do something to, make it so that you don't just get an undefined expression. So here you can just factor. Here you can factor the top into, well, you can take it, leave it as an x minus 6, but you can factor the denominator as an x minus 6 times an x plus 6. And then you can cancel those x minus 6 groups out. And then so you're just left then with the limit as x approaches 6 from the negative side of 1 over x plus 6. Now, if you can plug the number in, it doesn't really matter like if it's asking for the negative side or the positive side, because it's defined now. So don't overthink these ones, because sometimes students will get, hesitate when it's like, well, it can't be that easy. But if you can plug the 6 into x, plug in the undefined expression, you're good. So the answer is just 1 over 12. All right, let's look at another one now. Here we got an absolute value graph, absolute value of x minus 3 over x minus 3, and we're trying to find the limit as x approaches 3 from the negative side. Now, again, you want to see if you can plug in 3, and as long as you don't get an undefined expression, you can just evaluate and get that number, but you can obviously see that you'll get a 3 minus 3 in the bottom, and so you're going to be dividing by 0. So then you got to do something else. So here, one way I would advise is make sure you become very comfortable with what these absolute value graphs look like, because there's usually going to be like 1 or 2 on your AP exam. So you don't want them to sneak up on you. So whenever it's in a form like this, absolute value of like x minus 1 over x minus 1, or absolute value of x minus, 5 over x minus 5. This is just absolute value of x minus 3 over x minus 3. You're just gonna have 2 horizontal lines at negative 1 and positive 1, and they're gonna collide basically at x is 3. So you're gonna have a hole at 3, 1. So you're gonna have something looking like this. So you're gonna have a hole at 3, 1, and on the right side, your graph is gonna look like this. So it'll just be the line y equals 1. Because again, whenever x is more than 3, you're just gonna get a positive number in the bottom. Now on the left side of this, whenever x is less than 3, you're going to get a negative number in the bottom. So then you're going to have the horizontal line y equals -1. And you're going to have a hole here, 3, -1. Now, when we're talking about the one-sided limit from the left, you're going to be traveling along this line. So you're coming along this line to this point. And the value you're approaching is going to be -1. So the limit as x approaches 3 from a negative side of this function will then just be -1. Let's look at another one. Okay, here we have another one-sided limit where we have a piecewise function where g of x is square root of 1 minus x whenever x is less than or equal to 1. And it's the linear function x plus 1 when x is more than 1. And we're looking for the one-sided limit as x approaches 1 from the positive side. Now, here's the thing about these graphs. Even if you don't know what this looks like, and maybe you're having trouble graphing it, or maybe you just don't want to take time, if you can just pay attention to the domain and understand that if you're coming towards 1 from the positive side, that means you're approaching it from the right side, which means you're coming from values greater than 1. So whenever x is greater than 1, you're going to be along this line. Up until 1, then you switch to this line. Let me just draw, again, a visual of that line, just so it makes it a little more clear. But it has the equation x plus 1 whenever x is greater than 1. So it's going to have an open circle at 1, 2. It's going to have a hole there. And from the right out, it's going to look, the graph is going to look like this. We don't care exactly what the graph on the left looks like. What we care is that we're coming towards x is 1 along this graph, and our limit will then be the y value here, and that y value will be 1. So the limit as x approaches 1 from the positive side will be equal to 2. Let's go through one more. Here we have another piecewise function where we have f of s is equal to negative s squared minus 4s minus 2 when s is less than or equal to negative 2. And it's then equal to s squared plus 4s plus 6 when s is more than negative 2. And we're trying to find just the limit as s approaches negative 2. So we're not looking for any specific side. We're not looking for the right side or left side. We're just trying to find a limit in general. Okay, so like, again, let's say, you don't have a graph and you don't want to go through the, tedious work of making the graph. So like, what's one other way to do it? Well, if the limit exists, again, we're not talking about one-sided limits. If the limit exists at negative 2, that means when you plug negative 2 into this equation and this equation, you should get the same value. If you do, then whatever that value is your limit. If you don't, then the limit does not exist there. So we're simply just going to evaluate f of negative 2. And we're going to plug it into here and here. Technically, you're supposed to plug it into here only, but let's see what happens when we also plug it into there. So first we plug it into there. You get negative 2 squared, which is a 4, plus 8, minus 2. So negative 4 plus 8, 4. And you'll get a 2 there. Now, when you plug in negative 2 into here, you're then also going to get a 4 minus 8 plus 6. And then you're also going to get 2. So see that, so when you plug negative 2 into both equations, technically you're only allowed to plug technically the function says you have to plug it into here. But if you were to plug it into here, you still get 2, the same as you would get here. So then that means the function is continuous. It connects from the left and right side at the y value is 2. And so then our limit at x or at s is negative 2 is just 2.